Hi, I'm Henry Brill. This is Show Your Work video 4. Doing two problems from this collection of problems, and yeah. Alrighty, so uh, first problem that I chose to do is this one from 5.4, this one from 5.5. Alright, so finding the general solution to this non-homogeneous ordinary differential equation. So first step, finding the characteristic equation and the solution to that. Well, we can see that it's going to be m squared plus, and I have the answers here just so we can, confirm that we're correct. But obviously we're still going to show the process. So m squared plus 8m plus 15, and we're doing the homogeneous characteristic equation. So it's going to equal 0. So from this, we could factor it, and we find that the two roots are -5, -3. Cool. So that's the first step. Now we have the complementary solution, which we'll do show by doing that. YC is C1. So we know it's going to be this form. The solution's in this form, but we know the complementary solution is going to be in the form, C1 e to the 1 root t, and then we got, C2 plus C2 e to the other root t. So it's going to be e to the -5t, and then e to the -3t, and then C1 times e to the -5t plus C2 times e to the -3t. All right, so, and that's because, our two roots, -5 and then -3. Boom. Okay, cool. So that is that. So that is our characteristic equation. So now to find the particular solution, we know since the right hand is this, and the exponent, this root, -4, is not a part of our set of our roots of our characteristic equation, e -5 and -3. So it's we can guess, we would guess different things based on if it were. We're going to guess this one for particular. I have the sheet in front of me. So yeah, we're going to guess this for where a is a constant, e to the -4t. And we're specifically choosing this form to guess because it isn't, the -4 right here is not a part of this. So now we're going to find the derivatives of this. First one is just, we power or chain rule, I guess technically. Derivative of this times normal. So -4a e -4t. And then we just, for the second derivative, same process, chain rule again. And it multiplies this -4, so we get +16. So double prime p. And we get 16a, and then e to the -4t. All right, so now that we have that, we make our substitutions for our original equation, this. So, this is just another way of writing y prime prime, and this is just another way of writing y prime. And we have those so we can make some substitutions. So y prime prime plus 8 times y prime plus 15 times y. And, our normal y is this. So this, and then boom, that's just make those substitutions. And then we will next solve for a. So first it was y prime prime So 16 a e negative 4t. And I think plus 8, or is it minus 8? Yeah, plus 8y prime. And we know y prime is this. And then was it just plus 15y? And then that so that equal our right hand side, negative 6 e to the negative 4t. Negative 4t. Boom, just like that. Okay, now we can factor out this a e to the negative 4t. And we get 16 minus 32, 8 times negative 4, and then plus 15. Boom. And then we are factoring out the ae to the negative 4t. Boom. Okay, so ae to the negative 4t now equals, same right-hand side, negative 6. So to solve for a, we can divide both sides by the e negative 4t. So this, okay, so we'll do that eventually, but solving for a, sorry, I lost the negative 6 there. Boom. Okay, so this is just negative 16 plus 15 is negative 1. So negative a equals, and then we're going to divide both sides by this, equals negative 6. So a equals 6. Cool. All right, now that we have a equals 6, we could substitute this in for like y of p, our particular solution, and then we add that to our this one. So let's first just, we're rewriting y of p with a as 6. So we now know y of p equals 6 e to the negative 4t. And now we know our general solution is just this plus this. So rewriting our general solution as yt equals c1e negative 5t plus c2e negative 3t, and then plus our 6e negative 4t. Now let's double check that. Yep, and that is just our answer right here. So perfect. Or they put the constants behind, but it's the same thing. Cool. So that is the answer to the first one. All right, now problem 2. So, yeah. So for this second one, for the second problem, also non-homogeneous, doesn't equal 0. We're going to use undetermined coefficients. That's what it instructs us to. Again, I have the answer here. So we're going to, since the right side has a sign, we're going to guess the particular solution, y of p, as we're going to guess that the particular solution, y of p, equals a cosine t plus b sine of t. so that's going to be our guess for this. So now we got to find two derivatives for this. The first derivative is cosine derivative of that negative sign, so negative a sine t and then derivative of sine is cosine, so b cosine t. And then now, that's a weird t. Okay, yeah, there. And then now y double prime. Take another derivative. So derivative of negative cosine, derivative of negative sine is negative cosine. So negative a cosine t. Plus, and then negative sine, because derivative of cosine is negative sine. So plus, minus, or just minus, b sine t. So now, once again, we're substituting this in. For our equation up here. So it's going to be y prime prime. Negative a cosine t minus b sine t. Then negative 3y prime minus 3 boom plus b cosine t, and then we got minus 4y, so minus 4 b sine t, and then this equals negative 136 sine t. Okay, sweet. So now what we have to do is just some simplifying, collect the cosine terms, which gets us to, let's see. So collecting the cosine terms, we got negative a minus 3b plus minus 4a, so that's negative 5a minus 3b. So, and we know that equals 0 because there's no cosine term over here. So we got, what was it? Negative 3b minus 5a. Yeah, 5a. Because we have 1 over here and 4 over here. Equals 0. Cool. And then clicking the sine terms, we know it's going to equal negative 136. Because that's the coefficient in front of sine. So clicking the sine terms, we got negative 1b plus 3a minus 4b. So so 3a 5b. Oh yeah, 3a minus 5b. Oh Yeah, 3a minus 5b. Perfect. Yep. Cool. So now solving the system of equation. I solved this system ahead of time. I guess here I'll just graph it on Desmos. So we'll just say let B is y, a is x. So minus 3y, what was it? Minus 5x equals 0. So that's that. And then next one was 3x minus 5y equals negative 136. So zooming out, we see they meet at negative 12, 20. So A is negative 12, B is 20. Okay, so once again, confirming, negative 12, 20. So we got those numbers from. So now we plug the A and B back into our original guess. A cosine t, B sine t. And we get y, p, t equals boom, that's it. So let's double check. Yep, that's their answer. Negative 12 cosine t plus 20 sine t. Boom. That is how it's done. All right. Thank you.